Hello, my name is Dale. Welcome back for chapter 3 of my Stroke of Insight by Jill Bolte Taylor. Chapter 3: Hemispheric Asymmetries. Scientists have been studying the functional asymmetries of the human cerebral cortices for more than 200 years. To my knowledge, the first person on record to suggest that each hemisphere actually had its own mind was Maynard Simon Dupuy in 1780. Dupuy claimed that mankind was homo duplex, meaning that he had a double brain with a double mind. Nearly a century later, in the late 1800s, Arthur Ladbruk Wigan witnessed the autopsy of a man who could walk, talk, read, and write, and function like a normal man. Upon examination of his brain, however, Wigan discovered that this man had only one cerebral hemisphere. Wigan concluded that since this man, who was only half a brain, who had only half a brain, had a whole mind and could function like a whole man, then those of us who have two hemispheres must have two minds. Wigan enthusiastically championed this duality of the mind theory. Over the centuries, various conclusions have been drawn about the differences and similarities in how the two hemispheres process information and learn new material. This subject gained tremendous popularity in the United States in 1970s. So this is like was discovered in the late 1800s, and then it didn't gain popularity until the 1970s. I just thought that was worth noting. Um, all right, so gained tremendous popularity in the United States in the 1970s following a series of split brain experiments where Dr. Roger W. Sperry surgically cut the fibers of the corpus callosum of people experiencing severe epileptic seizures. In his 1981 Nobel lecture, Sperry commented, under the conditions of commissurotomy, where background factors are equalized and where close left right comparisons become possible within the same subject working the same problem, even slight lateral differences become significant. The same individual can be observed to employ consistently one or the other of two distinct forms of mental approach and strategy, much like two different people, depending on whether the left or right hemisphere is in use. Since those early studies of split brain patients, neuroscientists have learned that the two hemispheres perform differently when they are connected to one another than when they are surgically separated. When normally connected, the two hemispheres complement and enhance one another's abilities. When surgically separated, the two hemispheres function as two independent brains with unique personalities, often described as the Dr. Jekyll and Mr. Hyde phenomenon. Using non invasive modern techniques, including functional imaging, fMRI, scientists are now capable of visualizing which specific neurons are engaged in performing a designated function in real time. Because our two hemispheres are so sorry about these words, but this is the first time I'm reading them, so it takes me a minute. Neuronally integrated via the corpus callosum. Okay, because our two hemispheres are so neuronally integrated via the corpus callosum, virtually every cognitive behavior we exhibit involves activity in both hemispheres. They simply do it differently. As a result, the world of science supports the idea that the relationship between the two cerebral hemispheres is more appropriately viewed as two complementary halves of a whole rather than as two individual entities or identities. It makes sense that having two cerebral hemispheres that process information in uniquely different ways would increase our brain's capacity to experience the world around us and increase our chances of survival as a species. Because our two hemispheres are so adept at weaving together a single seamless perception of the world, it is virtually impossible for us to consciously distinguish between what's going on in our left hemisphere versus our right hemisphere. To begin, it is important to understand that hemispheric dominance is not to be confused with hand dominance. Dominance in the brain is determined by which hemisphere houses the ability to create and understand verbal language. Although the statistics vary depending upon whom you ask, virtually everyone who is right handed, more than 85% of the US population, is left hemisphere dominant. At the same time, more than 60% of left handed people are also classified as left hemisphere dominant. Let's take a closer look at the asymmetries of the two hemispheres. Our right hemisphere, which controls the left half of our body, functions like a parallel processor. Independent streams of information simultaneously burst into our brain via each of our sensory systems. Moment by moment, our right mind creates a master collage of what this moment in time looks like, tastes like, sounds like, smells like, and feels like. Moments don't come and go in a rush, but rather are rich with sensations, thoughts, emotions, and often physiological responses. Information processed in this way allows us to take an immediate inventory about the space around us and our relationship to that space. Thanks to the skills of our right mind, we are capable of remembering isolated moments with uncanny clarity and accuracy. Most of us can remember where we were and how we felt when we first heard about the assassination of President Kennedy or saw the collapse of the World Trade Center. Do you remember the moment you spoke the words I do or first saw your newborn smile? Our right hemisphere is designated to remember these things as they relate to one another. Borders between specific entities are softened, and complex mental collages can be recalled in their entirety as combinations of images, kinesthetics, and physiology. To the right mind, no time exists other than the present moment, and each moment is vibrant with sensation. Life or death occurs in the present moment. The experience of joy happens in the present moment. Our perception and experience of connection with something that is greater than ourselves occurs in the present moment. To our right mind, the moment of now is timeless and abundant. In the absence of all rules and regulations that have already been defined as the correct way of doing something, our right mind is free to think intuitively outside the box, and it creatively explores the possibilities that each new moment brings. By its design, our right mind is spontaneous, carefree, and imaginative. It allows our artistic juices to flow freely without inhibition or judgment. The present moment is a time when everything and everyone are connected together as one. As a result, our right mind perceives each of us as equal members of the human family. It identifies our similarities and recognizes our relationship with the marvelous planet, which sustains our life. It perceives the big picture, how everything is related, and how we all join together to make up the whole. Our ability to be empathic, to walk in the shoes of another, and feel their feelings is a product of our right frontal cortex. In contrast, our left hemisphere is completely different in the way it processes information. It takes each of those rich and complex moments created by the right hemisphere and strings them together in timely succession. It then sequentially compares the details, making up this moment with the details making up the last moment by organizing details in a linear and methodical configuration. Our left brain manifests the concept of time whereby our moments are divided into the past, present, and future. Within the structure of this predictable temporal cadence, we can appreciate that this must occur before that can happen. So, this must occur before that can happen. Okay. I look at my shoes and socks, and it is my left hemisphere that comprehends that I must put my socks on before my shoes. It can look at all the details of a puzzle and use the clues of color, shape, and size to recognize patterns for arrangement. It builds an understanding of everything using deductive reasoning, such that if A is greater than B and B is greater than C, then A must be greater than C. Just opposite to how our right hemisphere thinks in pictures and perceives the big picture of the present moment, our left mind thrives on details, details, and more details about those details. Our left hemisphere language centers use words to describe, define, categorize, and communicate about everything. They break the big picture perception of the present moment into manageable and comparable bits of data that they can talk about. Our left hemisphere looks at a flower and names the different parts making up the whole: the petal, stem, stamen, and pollen. It dissects the image of a rainbow into the language of red, orange, yellow, green, blue, indigo, and violet. It describes our body as arms, legs, a torso, and every anatomical, physiological, and biochemical detail one can imagine. It thrives on weaving facts and details into a story. It excels in academics, and by doing so, it manifests a sense of authority over the details it masters. Via our left hemisphere language centers, our mind speaks to us constantly, a phenomenon I refer to as brain chatter. It is that voice reminding you to pick up bananas on your way home and that calculating intelligence that knows when you have to do your laundry. There is a vast individual variation in the speed at which our minds function. For some, our dialogue of brain chatter runs so fast that we can barely keep up with what we are thinking. Others of us in language, others of us think in language so slowly that it takes a long time for us to comprehend. Still, others of us have a problem retaining our focus and concentration long enough to act on our thoughts. These variations in normal processing stem back to our brain cells and how each brain is intrinsically wired. So, that first thing is me, is of like where I have 1,000 thoughts a second. And I prefer to watch videos in double speed and even my own because that's how quickly my thoughts and words are processing, but I can't get them out that fast. Okay. So it's like, that's how I can like pick up on thoughts and patterns really quickly, is because my brain is always working so fast. So I have to use that to my advantage and like do something with it, or when I'm thinking of things, write things down in order to slow that down and remember them, or else I'm like overwhelmed and I lose focus and attention. Okay. That's why it's so beneficial to learn about how your brain works, because then you can understand how to work with it better. Okay. So, one of the jobs of our left hemisphere language centers is to define ourself by saying, I am. Through the use of brain chatter, your brain repeats over and over again the details of your life so you can remember them. It is the home of your ego center, which provides you with an internal awareness of what your name is, what your credentials are, and where you live. Without these cells performing their job, you would forget who you are and lose track of your life and your identity. Along with thinking in language, our left hemisphere thinks in patterned responses to incoming stimulation. It establishes neurological circuits that run relatively automatically to sensory information. These circuits allow us to process large volumes of information without having to spend much time focusing on the individual bits of data. From a neurological standpoint, every time a circuit of neurons is stimulated, it takes less external stimulation for that particular circuit to run. As a result of this type of reverberating circuitry, our left hemisphere creates what I call loops of thought patterns that it uses to rapidly interpret large volumes of incoming stimulation with minimal attention and calculation. Because our left brain is filled with these ingrained programs of pattern recognition, it is superb at predicting what we will think, how we will act, or what we will feel in the future based on our past experience. I personally love the color red and am inclined to collect a bunch of red things. I drive a car and wear red clothes. I like red because there's a circuit in my brain that gets very excited and runs relatively automatically when anything red comes my way. From a purely neurological perspective, I like red because the cells in my left brain tell me I like red. Okay, just a sidebar, I tend to not like the color red because it's too bold. Now, I also have foundational problems, which would be considered root chakra problems if you understand the energy centers of the body. And that is, um, I guess it's based on my past and things like that. But I have red pants on right now. So I did not know that this was coming up in the book. But when I feel like I need to have some like stability and foundation, I try to incorporate the color red either around me or like in what I'm wearing. Okay. So that's hopefully helpful. Among other things, our left hemisphere categorizes information into hierarchies, including things that attract us, or our likes, or repel us, our dislikes. It places the judgment of good on those things we like and bad on those things we dislike. Through the action of critical judgment and analysis, our left brain constantly compares us with everyone else. It keeps us abreast of where we stand on the financial scale, academic scale, honesty scale, generosity of spirit scale, and every other scale you can imagine. Our ego mind revels in our individuality, honors our uniqueness, and strives for independence. Although each of our cerebral hemispheres process information in uniquely different ways, the two work intimately with one another when it comes to just about every action we undertake. With language, for example, our left hemisphere understands the details of making up the structure and semantics of the sentence and the meaning of the words. It is our left mind that understands what letters are and how they fit together to create a sound, word, that has a concept or meaning attached to it. It then strings words together in a linear fashion to create sentences and paragraphs capable of conveying very complex messages. Our right hemisphere complements the action of our left hemisphere language centers by interpreting nonverbal communication. Our right mind evaluates the more subtle cues of language, including the tone of voice, facial expression, and body language. Our right hemisphere looks at the big picture of communication and assesses the congruity of the overall expression. Any inconsistencies between how someone holds their body versus their facial expression versus their tone of voice versus the message they are communicating might indicate either a neurological abnormality in how someone expresses himself, or it may prove to be a telltale sign that the person is not telling the truth. People who have damage in their left hemisphere often cannot create or understand speech because the cells in their language centers have been injured. However, they are often genius at being able to determine if someone is telling the truth, thanks to the cells in their right hemisphere. On the other hand, if someone has damage to their right hemisphere, they may not appropriately assess the emotional content of a message. For example, if I am playing blackjack at a party and I say, hit me, a person with a damaged right hemisphere may think I'm asking him to physically strike me rather than understand that I am simply asking for another card. Without the right hemisphere's ability to evaluate communication in the context of the bigger picture, the left hemisphere tends to interpret everything literally. Music is another great example of how our two hemispheres complement one another in function. When we methodically and meticulously drill our scales over and over again, when we learn to read the language of staff notation, and when we memorize which fingering on an instrument will create which named note, we are tapping primarily into the skills of our left brain. Our right brain kicks into high gear when we are doing those things in the present moment, like performing, improvising, or playing by ear. Did you ever stop to consider how it is that your brain knows how to define the dimensions of your body and space? Amazingly, there are cells in our left hemisphere's orientation association area that define the boundaries of our body, where we begin and where we end relative to the space around us. At the same time, there are cells in our right hemisphere's orientation association area that orient our body and space. As a result, our left hemisphere teaches us where our body begins and ends, and our right hemisphere helps us place it where we want it to go. I enthusiastically encourage you to explore myriad current literature about teaching and the brain, learning and the brain, and the asymmetries of our two cortical hemispheres. I believe that the more we understand about how our hemispheres work together to create our perception of reality, then the more successful we will be in understanding the natural gifts of our own brains, as well as more effectively help people recover from neurological trauma. The type of stroke I experienced was a severe hemorrhage in the left hemisphere of the brain, of my brain, due to an undiagnosed AVM on which was like arterial venous. I was trying to do it from memory, but I don't remember. Um, on the morning of the stroke, this massive hemorrhage rendered me so completely disabled that I describe myself as an infant in the woman's body. 2.5 weeks after the stroke, I underwent major surgery to remove a golf ball sized blood clot that was obstructing my brain's ability to transmit information. Following surgery, it took 8 years for me to completely recover all physical and mental functions. I believe I have recovered completely because I had an advantage. As a trained neuroanatomist, I believed in the plasticity of my brain and its ability to repair, replace, and retrain its neural circuitry. In addition, thanks to my academics, I had a roadmap to understanding how my brain cells needed to be treated in order for them to recover. The story that follows is my stroke of insight into the beauty and resiliency of the human brain. It's a personal account, as seen through the eyes of a neuroscientist, about what it felt like to experience the deterioration of my left brain and then recover it. It is my hope that this book will offer insight into how the brain works in both wellness and in illness. Although this book is written for the general public, I hope you will share it with the people who you want to help recover from brain trauma and their caregivers. Okay, that is the end of chapter 3, and I wanted to go back to see what AVM was because it was in chapter 2, arteriovenous malformation. Okay. And so if you don't remember what that was when the artery and the vein are connected directly instead of having capillaries in between to control and regulate the pressure from the artery, which has very forceful pressure, to the vein that does not have the pressure. It just receives it from the artery. Okay. It receives the oxygenated blood. All right. So the AVMs happen in younger people, and that's the less common stroke, but that is what she had. All right, so that's kind of our little recap, and we will come back with chapter 4. Okay.